Let's talk about how to calculate the pressure in a liquid which is of some particular depth. Okay. To understand this one, it's very simple. Imagine you're at the bottom of a swimming pool. You feel pressure, correct? If you're on the surface of the pool, you don't feel the pressure. That means as you go down, there is some increase in the pressure. Let's mathematically derive how it can be calculated. Now look at this particular figure. What you have a beaker of water, and in the beaker of water, we have a cylinder, correct? Now, in this one, say the density of this particular liquid. Let's call the density as rho. Okay, let rho be the density. Okay, now you have a cylinder, correct? Say the cylinder, it has a vertical distance, isn't it? Let's call this vertical distance as h. In the sense, height can be called as the height is the vertical distance, or you can call it as h. All right. Now you have 2 points, C and D. So if you look at this, C is on the top, D is in the bottom, correct? Now what you have, this CD becomes the axis of the particular cylinder, correct? And it has a cross-sectional area of A. So capital A is the area of cross-section. Area of cross-section is A, capital letter A. All right. Now, how can we calculate the mass of this particular body? Mass is what? Density into the volume, correct? So we can say that mass m is equal to volume into density. And what is the volume? A into h. Capital A is the area, h is the height, into rho, which gives us A into h into rho. This gives us the mass of the particular cylinder, correct? Now, the pressure in the particular point C and particular point D. Okay, this has to be very, very specific. See what we are doing. Let's say the pressure at point C. See at this point, say that particular pressure be P1. And at point D, let this be P2. So P1 is at C and P2 is at D. These are the two pressures. Correct? Now, what is the formula for pressure? Pressure is force per area. Correct? Now, in this case, what you're going to have, the force F1 is equal to P1 into A. Now, how is the force F1 acting on the particular body? Okay, especially on the top of the cylinder. Now, if you look at this one, see the force is going to be acting downwards here. This is going to become F1 because the pressure inside the liquid, it's pushing the body, correct? So F1 is acting like this. Now at D, at point D, you are going to have the second force, correct? So in the second force, you can call this as F2, which is acting this way. This is F2. So F2 is equal to P2 into A. All right. Now let's try to understand how we can calculate or how we can equate these two. See, now what you have, this is F1, P1A, F2 is equal to P2 into A. There is one more force which is acting on the body, which is a very important one. That is the weight of the body. So from here, you have the weight which is acting downwards, which is mg. All right, mg is the weight of the body. Now what you do, you take the third one also, which is m into g, which is the weight of the body. So there are three forces acting, F1, F2, mg, correct, or the weight of the body. Now what we have, since the body is in the equilibrium, we have to consider the total force acting on the body, correct? The net force acting on the body. Now look at the particular diagram. You can figure out that which two adds up, and those two sum is equal to what? Correct? Now look at this one. You have F1 plus mg is equal to F2. Isn't it? F1 plus mg is equal to F2. Now add these two. Now what is F1 value? F1 is equal to P1A plus mg is equal to P2 into A. Correct? Now what is M? M is equal to AH into rho. Correct? Now substitute that one. You are going to get P1A minus P2A. Take it this side. P1A minus P2A is equal to minus mg, or you can write P2A minus P1A is equal to m into g. So A into P2 minus P1 is equal to AH rho into G. Now A and A cancels. You get P2 minus P1 is equal to rho G H. Correct? P2 minus P1 is equal to rho GH. Now, what does this P2 minus P1 is equal to rho GH means? This is the next point. Now, P2 minus P1 is the pressure difference, isn't it? Pressure difference between which two points? Pressure difference between the point which is at the bottom and the point which is at the top. Correct? Now, what if the 2 points are at the same level? Okay, what if the 2 points are at the same level? Then what happens? You're going to get P2 minus P1 is equal to 0, or P1 is equal to P2. Now this is for same level. If 2 points are of the same level, you get P1 is equal to P2. Are you all clear with this? So to understand what is the pressure at a depth, at a particular depth, we are going to use the formula P is equal to rho G H. This is the formula what we generally use. Rho is the density, G is the acceleration due to gravity, and H is the height, in the sense height or the depth you can call it. Understood? This becomes the formula, or this is how we derive the formula to calculate the pressure at a particular depth.